Here is solution to question number 2 of your test on creating rational functions with given conditions, right? As you know, you could have more than one answer, right? But the idea is some of the factors will always be common, right? Now here the question is, create a rational function with vertical asymptotes at x equals to 1 and x equals to minus 3, and horizontal asymptote at y equals to 0 and y-intercept at 2. So what we can do is, it is not necessary to sketch or even draw on the side. You could straight away write down the equation, right? But I'm just trying to draw a sketch here to explain you few things. I will actually not sketch the graph, okay? So let's create a rational function with vertical asymptotes at 1 and minus 3. So let us say this is my vertical asymptote at 1 and this is my vertical asymptote at minus 3, right? So that's my point, minus 3, and this is 1 for me, right? And a horizontal asymptote at y equals to 0. So basically, we have a horizontal asymptote which is kind of this, right? We will just draw it. That is my horizontal asymptote at y equals to 0. And a y-intercept at 2. And somewhere here is our y-intercept. So this is something which we are looking forward to, right? Now, so we can draw any kind of function which will fit into this situation. So we'll start writing down our equation now. We'll say, well, f of x should be equal to what? So first let's go with the vertical asymptotes. Vertical asymptote at minus 3 means a factor in the denominator which should be x plus 3. Now if I plug in minus 3, that becomes 0 and give me a vertical asymptote. Vertical asymptote at 1 means x plus 1 is a factor in the denominator, right? And now another condition which we have is horizontal asymptote at y equals to 0. Horizontal asymptote for this condition means that my numerator degree should be less than 2. When I multiply these two, I get x squared. So my numerator could be x or even a constant. Now, y-intercept of 2. Y-intercept of 2 means that if I plug in 0 for x, then I should get 2, right? Now here in this equation, if you put 0, what do you get? So I'm sorry, this is minus 1. No, because this is plus 1, so this has to be minus 1, okay? Sorry for that. Now, when I put x equals to 0 here, what do I get? I get, let me write this again here. So if I put 0 here, I get 0 plus 3 times 0 minus 1. So when I multiply these two, I get minus 3. Now, but I need 2, right? So how can I get 2 when denominator has minus 3? That means I should have minus 6 on the top. Now if I divide minus 6 by minus 3, I'll get 2. So therefore, this should be minus 6. Do you understand? And I get, well, my function f of x is equals to minus 6 over x plus 3 times x minus 1. Do you understand? So that is my final answer. That is my answer, right? So I say my answer is this. But these are the steps which help you get the equation. It is not always simple to get this kind of equation, right? But you know, we can get it in many different ways. So this is, I think, the easiest way of getting this equation, right? You can always sketch this equation. That is not a problem. Well, we are not going there. But in any case, I hope you understand the way of getting the equation. My purpose of keeping vertical asymptotes same because with every question we are trying to graduate and learn a new angle to the same equation, correct? So that is the whole idea. Well, I could have given alternate solution for this, and that is some of you could do red, because we know that for horizontal asymptote of y equals to 0, degree of numerator should be 1 less or less than that, maybe anything less. So I could have even written x minus 6 over x plus 3 times x minus 1, right? That will also fulfill all these conditions, right? Degree of numerator is 1, degree of numerator is 2, 1 less. Therefore, horizontal asymptote is at y equals to 0. And if I plug in 0 here, 0 here, I get minus 6 divided by minus 3, which is 2, right? So the conditions are met. So this or any similar one will be a solution to this question. Okay, I hope you appreciate it. Thank you.